All right, folks, we're just going to go through a little bit of a factoring review here. First thing you need to look at is, or you need to decide which method of factoring do you choose. And you should always follow these 3 steps. Okay? Step 1 being the most important. You should always try and take out a common factor first. If it doesn't have a common factor, then you move on to step 2. Okay? If it doesn't have a common factor, step 2 is saying if the expression is a binomial. Binomial means 2 terms. Then try and do the difference of squares. Difference of squares look like this, or looks like this. A squared minus b squared factors down into a minus b times a plus b. You take the square root of the first term, the square root of a squared goes to the front of each bracket, so there's an a at the front. And then I take the square root of b squared, which would be b. I put it at the back of each set of brackets, and we put opposite signs between them, a minus and a plus. So if there's no common factor and it has 2 terms, do the difference of squares. If there is no common factor and it has 3 terms, okay, can't be the difference of squares if it has 3 terms. If it's a trinomial, 3 terms, then we're going to look at either a simple trinomial or a hard trinomial. Simple trinomial, there will be a 1 in front of the x squared. A hard trinomial, there will be some other number, another coefficient other than 1, so 2, 3, 4, 5, so on, in front of the x squared. So, what I'm going to get you to do, all right, is I am going to get you to copy these examples down onto a separate piece of paper. You can pause the video right now. You copy those down onto your loose leaf, and I'm going to go through these examples with you. So pause the video, copy them down. Once everyone has them copied down, press play again, and we'll get going. All right. So before we get back into this, I just want to go back a slide. These are examples of common factoring. If you see g to the 4th x squared minus g to the 9th times x to the 5th, there's 2 terms, both have a g and both have an x. Remember, you would take out the lowest exponent, so g to the 4th, and I would take out x squared. 22w to the 7th minus 88z to the 14th. Those 2 numbers are both divisible by 22. 4r to the 8th minus 16r to the 7th s to the 9th plus 2r to the 10th. 4, negative 16, and 2 are all divisible by 2. And these 3 terms, they all have an r. r to the 8th, r to the 7th, and r to the 10th. So I would actually take out a 2r to the 7th. Then I would open a bracket. I would divide all 3 of these terms by 2r to the 7th, starting with 4r to the 8th. 4 divided by 2 is 2. R to the 8th divided by r to the 7th would be r to the 1st. When you divide powers with the same base, you subtract the exponents. Negative 16 divided by positive 2, that would be negative 8. R to the 7th divided by r to the 7th would be r to the 0. Subtract the exponents, and then s to the 9th would just follow down. Then I'm going to move on to the 3rd term. 2r to the 10th divided by 2r to the 7th, that would be 1r to the 3rd. 2 divided by 2 is 1. R to the 10th divided by r to the 7th would be r to the 3rd. Shut the door, or shut the bracket. Then I'll clean this up. 2r to the 7th times 2r minus 8s to the 9th plus r to the 3rd. R to the 0 is just 1. Anything to the power of 0 is 1. So negative 8 times 1 times s to the 9th would be negative 8s to the 9th. So it's got 3 terms. 1, 2, 3. Nothing in common to all 3. 1, 2, 3. Nothing in common to all 3. 1, 2, 3. Nothing in common to all 3. The first 2 are simple trinomials. The 3rd one is a hard trinomial. If it's got 2 terms, a perfect square minus a perfect square, it has to follow that form. Something squared minus something squared, then you can do the difference of squares. Okay, difference of squares. Difference is the answer you get when you subtract. Squares are perfect squares. X squared and 16, or 64v squared minus 81. So nothing common to both of those terms. What I would do is I would set up my template. I would know to move to step 2. Okay, there's nothing common to the 64 and the 81. No greatest common factor. Move on to step 2. I can see that it's got 2 terms. It's going to follow this pattern right here. What I do is I take the square root of the first term, 64v squared. The square root of 64 would be 8. The square root of v squared would be v. So I would put an 8v to the front of each bracket. Then I move on to the second term, 81. The square root of 81 is 9. I will put a 9 at the back of each bracket. And then I just have to remember to put opposite signs between them, a plus and a minus, or a minus and a plus. It wouldn't matter if you wrote this as 8v minus 9 times 8v plus 9. It really doesn't matter the order of your factors when you're multiplying. It's like saying 3 times 4, that's 12, or 4 times 3, it's also 12. Both of these would be correct. Now these ones, I'll show you some examples right along here in the next couple of questions. So the first thing I should try with number 1, is there anything common to all 3 of these terms? 1 term, 2 terms, 3 terms. I have 3 terms in that. 15, 30, and 60, they are all divisible by 15. M to the 5th, there's no M in this one. M to the 4th. So these 2 terms have an M, but this one doesn't, so I can't take out an M. Now I'll check for the n's. N to the 3rd, n to the 7th, n to the 8th. They do all have an n. I have to take out the one with the lowest exponent, so I'd take out n to the power of 3. P to the 1st, p to the 3rd, p to the 5th. They do all have a p. I will take out the one with the lowest exponent, or p to the 1st. Then you open a bracket. We are going to divide this term, term 1, by the common factor. 15 divided 15 is 1. The m to the 5th is going to come down. N to the 3rd divided by n to the 3rd would be n to the 0, or a 1, so I don't have to write it. P to the 1st divided by p to the 1st would be p to the 0, which is 1. I don't have to write it. Move on to term 2. Term 2 divided by the common factor. Negative 30 divided by 15, that's negative 2. N to the 7th divided by n to the 3rd, that's n to the 4th. P to the 3rd divided by p to the 1st, that's p to the 2nd. You subtract the exponents. 60 on to term 3. 60 divided by 15, that's going to give me a positive 4. M to the 4th is just going to follow down. There is no m here. You can think of it as an m to the 0 there. N to the 8th divided by n to the 3rd leaves you with n to the 8 minus 3, or n to the 5th. P to the 5th divided by p to the 1st would leave you with p to the 4th. Don't forget to shut the bracket. And that's it. It's factored. It's all done. Don't have to do anything with this inside. Number 2, here's an example of a trinomial. First thing I should try is take out a common factor. There is nothing common to 1, negative 2, and negative 35, and all 3 of those terms don't have an x. This is a simple trinomial. I look for 2 numbers that add to give negative 2 and multiply to give negative 35. So it adds to give this middle number and multiplies to give the last number. Write down the factors of negative 35. Okay, what multiplies to give you negative 35? So 1 times 35. I know that one of these numbers has to be a negative, because the only way you can multiply 2 numbers together and get a negative answer is if you go a positive times a negative, or a negative times a positive. So in order to figure out which one's a negative, I look at this. If they add to give you a negative, it means the larger factor, the 35, should be the negative. If they added to give you a positive, I'd make this a positive, the larger factor would be positive, and this would become a negative. All right? The only other numbers that multiply to give 35, or negative 35, would be 5 times negative 7. So So when I inspect these numbers, it's these guys that would satisfy both of these constraints. 5 plus -7 is -2. 5 times -7 is -35. My answer looks like so. I would put an X at the front of each bracket, and then I would say plus 5 in this one and -7 in this one. Again, it doesn't matter if someone writes X minus 7 times X plus 5, same thing. Okay, when I multiply this by this, I would end up with this. X squared minus 7x plus 5x minus 35. Negative 7x plus 5x would combine to give you the negative 2x. Moving on to number 3. First thing I should try, common factor, 270, 180, and 90. They are all divisible by 90. So this is a common factor. It's the same as number 1. It was a common factor. So they're all divisible by 90. X to the first, x cubed, x to the first. They do all have an x. Lowest exponent is 1. Y squared, y to the first, y to the first. They all have a y. So I will take out an exponent of 1. Divide this term by this. 270 divided by 90 is 3. X divided by x would be 1. Y squared divided by y to the first would be y. Move on to the next term. Negative 180 divided by positive 90 is negative 2. X cubed divided by x to the first, x squared. Y divided by y would be 1. Third term. Negative 90 divided by positive 90 is negative 1. Don't have to write the negative 1. X divided by x would be a 1. Y divided by y would be a 1. So I do have to fill in 1. I don't have to write 1 times 1 times 1, but I do have to put 1. And again, you can see if you multiplied this by this, like if you followed 90xy times y, 3y, you'd get the 270xy squared. 90xy times negative 2x squared would give you the negative 180x cubed y. And 90xy times negative 1 would give you the negative 90xy. I'm going to do this one first, number 5, before I do number 4. Okay, nothing common, sorry. There is something common to these. 4x squared minus 14x and negative 8. They're all divisible by 2. 4x squared divided by 2 is 2x squared. Negative 14x divided by 2 is negative 7x, and negative 8 divided by 2 is negative 4. So I did a common factor. That's what I started with, and that's what you should always try first. Yikes. Common factor, and then I'm going to move into a hard trinomial. So what's left in the brackets, it has 3 terms. 1, 2, 3 terms. I look for 2 numbers that add to give that middle number again, so they're adding to give negative 7. But this time they have to multiply to give 2 times negative 4. 2 times negative 4 would be negative 8. So I'll go through that process again. What multiplies to give negative 8? That is a 1 times a negative 8. I know the larger factor has to be a negative because they're adding to give me a negative, so I make the 8 a negative. Or a 2 times negative 4. That's it. Those are my only options for multiplying to give negative 8. And if I'm looking for the ones that add to give negative 7 as well, that's the guys right here, 1 and negative 8. 1 plus negative 8 is negative 7. 1 times negative 8 is negative 8. The 2 out here is going to follow down. This hard trinomial, just like I did before, 2 brackets. X at the front, X at the front. I'm going to put a plus 1 and a minus 8 in there as well. That's these numbers right here. The thing about a hard trinomial is I have to divide each of these numbers by that coefficient in front of the x squared. So I'm going to divide them by 2. If this was a 3, I divide them by 3. If it was 5, I divide both by 5. We call it the slide and divide technique. Okay? If it divides evenly, and you do so. If it does not divide and give you a nice whole number, like 1 divided by 2 is 0.5, then we slide the 2 up in front of the x, and I'm going to rewrite this factor as 2 times x plus 1. On to the next one. 8 divided by 2 does divide evenly. It's going to give me a 4, or I could say negative 8 divided by positive 2 gives me negative 4. And that's my final answer. 2 times 2x plus 1 times x minus 4 equals the following. We'll move back to number 4. I don't think we've seen one like this with x's and y's. It is a hard trinomial. There is nothing common to all three of those terms. 5x squared plus 14xy plus y squared. They don't all have an x. They don't all have a y. And 5, 14, and negative 3, the only thing common to those would be 1. So I need to look for two numbers that add to give that middle number, 14. And the same two numbers have to multiply to give negative 15. Where am I getting the negative 15 from? 5 times negative 3. Okay, what multiplies to give negative 15? 1 times 15. Now hold up a sec. We've always been putting the negative with the larger, okay? But this time, they're adding to give me a positive, so that means the larger factor should be a positive. The 1 would get the negative. 3 times 5, the 3 would get the negative. And if I'm asking myself which numbers add to give positive 14, it's these guys. Negative 1 and 15. So I will write two brackets. I will put an x at the front of each bracket. I will put a minus 1 and a plus 15. But I got to account for this y and this y squared. So I'm going to throw a y after these guys. And then once again, I will divide by 5. Why am I dividing by 5? That is the coefficient in front of the x squared. 1 over 5 does not divide evenly. It's 0.2. So I'm going to slide this up, and I end up with 5 times x minus 1y, or 5x minus y. This next bracket, x plus 15y divided by 5, would be 3y. That is the answer. 5x times x gives me the 5x squared. 5x times 3y gives me 15xy. Negative y times positive x gives me negative xy. If I combine those, 15xy minus 1xy, I'd get the 14xy. And then if I go the last times the last, negative 1 times positive 3, negative 3, y times y, y squared. So you can do a quick mental check to make sure you have these right. Last question is a difference of squares. There is nothing common to either of these. So it is the difference of squares because it only has two terms. Now, that doesn't necessarily mean it is a difference of squares. Okay? It has to be a perfect square minus a perfect square. So I set up my template, two brackets. I ask myself, what is the square root of 4x squared? Square root of 4 is 2. The square root of x squared is x. I drop a 2x at the front of each bracket. Do the same for the 49. What is the square root of 49? 7. Okay? I put a 7 at the back of each bracket. And I just have to remember to put alternate signs, a positive in one and a negative in the other. And that, my friends, is it. Okay? Those are the 4 types of factoring that we have learned. Hopefully you were able to get some of them right. And now you can practice number 1 to 26 on the sheet provided.